So as we discussed, we're going to use our graphing calculator to finish this equation by finding an intersection point with the equation that we wrote previously. So I've gone ahead and already typed in the two sides of my equation. Type in one side of your equation is y1, the other side is y2. And what I want to look for is an intersection. Now I know this is going to be a parabola because I see eventually I would have x times x if I multiplied that out, so there's x squared. And then y2 is going to be a horizontal line, 480,000 spaces up. So part of this is going to be adjusting my window so I can actually see my intersection point. So if you hit graph now, you're not going to see anything. So what I need to do is I need to first adjust my window so I can find an intersection. Because I know that this side of my equation is going to be that horizontal line, I know my y max needs to be at least that high to see that horizontal line. So I'm going to make my y max a little bit higher. I'm going to go 500,000. Okay. And if I try that window, let's see if I see anything. I've not changed my x's yet. So let's see if I see an intersection point. So I see part of my parabola. There's it slowly curving upwards, and there's the horizontal line. So this window is terrible. I'm looking for an intersection point, and I can see that that line curves, and eventually somewhere way out there, there'd be an intersection point. So let's go back to our window and adjust this time. Let's make our x max a little bit higher. I could also use the problem to help me figure out what kind of x values would make sense. Remember, x stood for how much land we're adding to our field. Right now it's 400 by 600 yards, and I want to double my area. So I'm guessing adding 10 yards is going to be insignificant. So I need a much higher number. Let's try adding, I don't know, let's try 500 yards. If I don't find an intersection, and if my window's no good, then don't get upset about it. Just try another window. So let's see this time if I can see an intersection point. So there's my parabola, part of it curving upward. There is my horizontal line, and good. I do see an intersection that I need. Now some of you might be thinking, well, what about that other intersection? Like if I follow my parabola backwards, it should also intersect here. Well, I'd have a negative intersection, and I don't care about adding negative area to my field, negative land. That doesn't make sense. So let's find just this intersection point. So hit second and trace if you forgot where to find intersection. Option 5 is what I want. It's going to ask you 3 questions. You can just go ahead and, if you want to trace, although my cursor is way off the screen right now, if you want to trace and get close to that intersection point, you can. Otherwise, just hit enter 3 times for first curve, second curve, and guess, and it'll find you your intersection point. So the solution to this is x equals 200. I should be adding 200 yards onto my field. Now, going back to the question, though, they do say, what are the new dimensions of the field? Well, let's go back and actually answer that question then. If I add 200 yards onto either side of that field, 400 plus 200 gets me 600 yards. And then this dimension, adding 200 more yards, gets me 800. So my new dimension should be 600 times 800. And if you just want to double check that that is the area you want, multiply it. 600 yards times 800 yards. We were looking for an area of 480,000. And ta-da, we got it. So I want to add on 200 yards, and 600 by 800 yards would be my new dimension. And that's how I can use my graphing calculator to solve this rather than solve by factoring.